Guys, here's the solution of the problem from Nootan Physics, chapter of electrostatics, and the problem says two positive charges distance 0.1 meter apart repel each other with a force of 18 Newton. If the sum of the charges be 9 microcoulomb, then calculate their separate values. So I have just stated the problem over here, and you can see I have here drawn two charges. This is Q1 and this is Q2, and they are separated by a distance of 0.1 meter apart, and they repel each other with a force of 18 Newton. Now we all know from the Coulomb's law the magnitude of the force can be given by the formula F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square, or you can also reiterate it as F is equals to C Q1 Q2 by R square, where C happens to be 1 upon 4 pi epsilon naught, and this value comes out to be 9.0 into 10 to the power of 9 in SI system of unit. Now the force of repulsion here as per the problem happens to be 18 Newton. What I'm going to do, I'm going to replace or put F is equals to 18, so it becomes 18 is equals to C Q1 Q2 by R square. Therefore 18 is equals to 9 into 10 to the power of 9 into Q1 Q2 upon R square, and R happens to be 0.1, so 18 into R square upon 9 into 10 to the power of 9 is equals to Q1 Q2, or Q1 Q2 is equals to 18 into 0.1 ka square upon 9 into 10 to the power of 9. 2 is 18, so it becomes 2 into 10 to the power of minus 2 minus 9 is equals to 2 into 10 to the power of minus 11. Now I leave it in SI unit. Now then further it says the sum of the charges. So when they are talking about the sum of the charges, therefore Q1 plus Q2, this happens to be 9 microcoulomb. Now this is the point where most of you are going to commit the mistake. What most generally students do from here onwards, they simply put Q1 is equals to some value, means 2 into 10 to the power of minus 11 upon Q2 into the expression or into the equation number, let me call it as equation number A. So in the equation number A, and then they form a quadratic. Now this is the area where you all are going to commit a mistake. Quadratics are always difficult for us to solve. I prefer another approach. What I'm going to do, I'm going to take a famous identity of from algebra, and that happens to be x minus y whole square is equals to x plus y whole square minus 4xy, or I can say Q1 minus Q2 whole square is equals to Q1 plus Q2 whole square minus 4 times Q1 Q2. This will give me an expression in Q1 minus Q2, and then I am going to solve Q1 minus Q2 and Q1 plus Q2 with the help of simultaneous linear equation. Now we already have got Q1 plus Q2, therefore what I can say, Q1 what I can say now, Q1 minus Q2 whole square is equals to Q1 plus Q2 was 9 micro, means 10 to the power of minus 6 ka whole square, minus 4 times of q1 q2, and we have already calculated the value of q1 and q2. q1 times q2, that was 2 into 10 to the power of minus 11. You can see over here that we had calculated that q1 into q2. So we are going to substitute it over here. 4 into 2 into 10 to the power of minus 11 in the place of q1 q2. So this becomes 9 square is 81 into 10 to the power of minus 12 minus 4 2s are 8 into 10 to the power of minus 11, or 8.1 into 10 to the power of minus 11 minus 8 into 10 to the power of minus 11. Simplifying it out, it becomes 0.1 into 10 to the power of minus 11, or q1 minus q2 का whole square is equals to 10 to the power of minus 12, or simply q1 minus q2 is equals to 10 to the power of minus 6. Now I've got the value of q1 minus q2 as 10 to the power of minus 6, or 1 into 10 to the power of minus 6. Now I'm going to use the help, or I'm going to take the help of simultaneous linear equation, that is q1 plus q2 was 9 microcoulomb, while q1 minus q2 was 1 microcoulomb ka square, and this was also a square. No, it's not a square, sorry. So solving it out, it becomes 2q1 is equals to 10 microcoulomb, or q1 is equals to 5 microcoulomb. Substituting it in any one of these simultaneous, in any one of the above equations, so it will be q1 minus q2 being equals to 1 microcoulomb, or simply q2 is equals to 4 microcoulomb. That's the answer. One charge being 5 microcoulomb, while the other charge being 4 microcoulomb. The complexity of the problem was lying onto the fact of whether you get into a quadratic equation and create a problem for yourself, or whether you are mathematically more intellectual and utilize the simultaneous linear equation technique and get an answer. This is going to be often utilized in number of the numerical problems. So candidates, learners, take care, students. Whenever you get such type of problem, never get into a quadratic equation. Always try to frame a simultaneous linear problem. If you find a sum of any two charges, or a negative or difference of any two charges given along with the product of the charges, that's going to be quite useful. Take care, enjoy it out.